So this is the most important author in internal medicine. This guy's name is Tinsley Harrison, and every internist in the world has read his book, The Principles of Internal Medicine. And one of the conclusions that people usually think is they think that he must be the original, must be the first author of a medical textbook. That's why it's the standard. But that's actually not the case. Cecil was the first. Russell Cecil, a prominent New York physician, created the first medical textbook and was really the standard from about 1930 to 1964. And the reason for this was very clever. He got 130 authors to write it. It's the first multi-author medical textbook. And he picked one author from every medical school in the country. So what medical school would not recommend them using Cecil's because it was the book that their own faculty wrote. It was a very good marketing move. And Cecil had a very particular organization to that you would have a disease, and then under that disease it would give the definition, the pathology, and the epidemiology, and the symptoms to that. But the book becomes rather useless if you don't have a diagnosis, right? If you don't know what the patient has and you're trying to figure it out, and the patient has a headache, you have to jump all over the book. And Tinsley Harrison just reversed this. And he said, well, let's start with the symptoms and then go from there to the disease. It was released in 1950, and in 1964 it passed the sales of Cecil's, and it has never looked back, and it is still the champion. And it'll probably never be passed. This is the best-selling internal medicine textbook of all times. But times have changed, right? So this gentleman, Burton Rose, has probably done more for modern medical education than anybody else. If you talk to him, he'll immediately tell you to call him Bud Rose. And quite honestly, if you were writing a fiction book and you named a character Rosebud or Bud Rose, nobody would believe it. But that's honestly his name. And he's the creator of Up to Date, which is the definitive medical resource. Now, I don't have any sales data to prove that it's the definitive, but I work at an academic center and I interview people that want to be nephrologists. And I've been there for about 12 years, and I interview about 12 people a year, so that's about 144 people. And I ask everybody I interview the same question. Now, they may not think it's the same question, right? So for a group of people, I was asking them about propylene glycol toxicity in the ICU. And another group, I was asking them about Aristolochia exposure in the clinic. And maybe another group of people, I would ask them about use of L-carnitine in the dialysis unit. And the intention of these questions was just to get the interviewee to go, I have no idea what the hell you're talking about, Dr. Topf. Right, and I thought that was a useful question, right? Because the idea was that as a fellow, you're going to come across things you've never seen before, that you have no idea what you're going to do. And I wanted to know how the applicant reacted to that uncertainty. And I thought it was a great question. It ends up not being so interesting because 144 times I've asked this, and 144 times I've gotten the same answer. Either the first or second answer every time was up to date. And so, it's like there's a new champion in the world now. It's Conor McGregor, but it's not boxing. It's not the sweet science. It's the violent and fast sport of MMA. And you can ask Burton Rose why he thinks it's so successful. Or you don't have to ask him. You can just go to YouTube and you can watch the interview. And he attributes it to this. He says that when they want to write a new edition of Harrison's, the first place they go to the marketing department, because the most important question is, how much is it going to cost? And once you figure out the book is going to cost $250 or so, you take that to the production department. And the production department says, well, for $250, and if we want to make this certain profit rate, we can make a book that's precisely 4,012 pages long. You take that 4,012 pages long, you send that to the editors. And the editors then have to distribute those 4,012 pages among 397 chapters, from the practice of medicine to ectoparasite infestations and arthropod injuries, chapter 397, which is a fine way to write a textbook until this happens, right? So this past fall, empagliflozin was shown to reduce mortality. This is the very first time ever that a drug for type 2 diabetes was shown to reduce mortality. Right? And you think we've been treating diabetes since the 1920s, the first time we've actually been able to show a mortality difference. This is huge. Now, this may be overturned in a future trial. But for right now, this is the kind of thing that has to be in Harrison's, right? If you're able to show mortality benefit, this has to be in there, which is all right, right? We're going to add it into Harrison's, but we're still limited to 4,012 pages. So if we add a page on empagliflozin, we have to remove something else. So kind of definitionally, as medicine advances, Harrison's has to get worse. And up to date, because it is delivered on now on the internet, but originally on CD-ROM, it didn't have these limitations. And that's why Bud Rose thinks it wins. But I don't think that's why medical students use it. I don't think anybody looks at 4,000 pages of Harrison and says, it really needs to be longer, right? I think what we're actually looking at is up to date because it's delivered electronically. It's the medical text that's with you. Anytime you can get to a computer, you can have definitive access to medical information. And more importantly, even though Harrison's had much better search than Cecil's, having regional and symptomatic organization, full random access of modern text is definitely superior. So I think this is why UpToDate wins. So UpToDate really is just a tool that was natively designed for the tools that were available in 1990, the personal computer, and it trounces Harrison's. So it wins because it's fast, wide, and deep. And so we had Harrison's, and now we have Rose. And the question that I have is, what are we going to have tomorrow? What is going to replace UpToDate? And maybe the answer is nothing. Maybe this is as good as medical references can ever get. But to me, what I keep coming back to is it really was designed for a tool of the 90s, the PC. And in January of 1997, Steve Jobs pulled this out of the pocket, and this changed everything. It's amazing how engaged we all are with these mobile devices. And I think the change is so dramatic, it's going to inform future generations of these medical textbooks. You read these statistics that there are more cell phones than toilets, right? I show this to my son. I have a 13-year-old son. I said, "What do you think about this?" And he said, "Well, looks like there's about 1.5 billion people that don't need to worry about dropping their cell phone in the toilet." And it's not just that we all carry these cell phones, it's what we use them for. So if you have an iPhone, you can do this right now. You can reach into your pocket, you can go to the settings application. In the third group down in settings, there's an application called Battery. And it's a little bit embarrassing, but it'll show you which applications you use the most in hours. And you can get to see which application you do. And so I asked a bunch of my friends to take screenshots of this and send it to me. And first of all, you can see what my friends are endlessly doing, first of all. They're all engaged in Twitter all the time. But what you see is that everybody is using social applications. They're using Facebook and Twitter and messaging applications and WhatsApp. These are what we carry these phones for. We just love to gossip. And that's, of course, hugely selection bias. If you take a look, though, more generally, look at a general group. This is the most popular apps of 2015. 4 of the top 8 are all social applications. So, again, I don't know exactly what's going to replace UpToDate, but I can't believe that it won't be informed by these twin advances of social and mobile. But if you look at the social landscape, that might terrify you, right? This is the most retweeted picture of all times. It's from the Oscars. And you look at the social landscape, and it doesn't look very productive. These are the 3 most followed people on Twitter: Taylor Swift, Justin Bieber, and Katy Perry, in that order. If you want to go to Facebook, these are the 3 most liked pages: Cristiano Ronaldo, Shakira, and Vin Diesel. Really? Number 3, Vin Diesel. And so the social landscape is just a bunch of junk food. And if we want to have medical education there, we need to improve the nutrition of that diet. Or in other words, how do we go from Kylie Jenner to Edward Jenner? And so I'm going to kind of lay out what we're doing in the nephrology space. But this did not come out of a very planned step-by-step. It really kind of had been haphazard. And looking backwards now, it seems to make more sense. But we're not as smart as it looks like we are. So this is the schema that we're using right now. Is we have blogs at the bottom. Then we have a layer of tweets or social media on top of that. Then we have a couple of tentpole events on top of that, and then we seal it all up with these monthly chats. I'm going to go through each one of these elements one by one. I want to start with blogs. And so blogging's kind of fallen out of favor. It's not the hot new thing, but it really is super important for what we're doing. That compared to other social media, it's a lot more thoughtful and deliberate than a tweet. They're longer, of course, and most importantly, most of social media is very ephemeral. Like you write it, it's there, and then it goes away, unless it's embarrassing to you, and then it never disappears. But most of the good stuff immediately disappears. But blogs have a permanence that is really important. And I want to kind of talk about the type of blogging that I'm talking about. I'm not talking about the kind of stuff you'll read on KevinMD, which is personal stories about physicians or about the difficulties of being a doctor. I'm really talking about the science of medicine. This is not Jordan Grumet's stuff, who spoke here a couple of years ago. So, this is my personal blog. Here's a couple of typical posts. So on the left, you have a primer. This is how the kidney works for people that are not nephrologists or not even doctors. On the right side is a postmortem. Not a postmortem, let me say. I had a patient with a very high potassium, and I had to make a call in the middle of the night to dialyze that patient, and I decided to dialyze them. But it was a questionable call, and so then I faced the question outward, and I asked people, what would you do? And I had about 50 responses, and I divided them up based on their training level to get a sense of what other people would do, which is kind of fun to do because you make these decisions all the time in medicine. You just don't know, you never know what the right one is. Here's two others. The one on the left is an editorial I wrote about an important study on dialysis patients called Evolve. And the one on the right, when the iPad came out, there was this kid in China who literally sold his right kidney for an iPad. And I kind of talked about the health implications of selling a kidney. So that's kind of what we're doing with blogs. And then I want to talk a little bit about tweets. And, there's a couple of ways you can tweet. You can tweet one way where you have something interesting, you send it out. But what's really interesting is when you get this two-way conversations. This is what really stimulates. And a lot of times these kind of feel haphazard and they just come about, but they can be great. So one day I got this tweet from a person called MedCalc. And MedCalc's actually a piece of software that I use on my iPhone. It's a medical calculator. And he asked, is the osmolality of D5W, one of the standard IV fluids that we use, 252 or 278 milliosmoles per kilogram water? Because my calculations say it's 278, but this chart here, and he gives a link, says it's 252. Am I wrong? And so I said, this is a straightforward calculation. There are 50 grams of glucose in a bag of D5W. The molecular weight of glucose is 180. So if you take 50 and you divide it by 180, then you multiply it at 1,000 because we're doing millimoles. You get 278, which is exactly what I think he got, and I think the chart is wrong. But then I saw the author. I know the author of that chart. I said, hey, I sent her a tweet. I said, hey, what's wrong? How'd you get this wrong? It looks like it's 272. And she said, well, I don't know. I just got it from here. And, which is, a lot of what happens on the web. People are reposting what may be errors. And so right there in the chart says it's 252. And then Brian Lee, who's a nephrologist in Honolulu, he pops up and he says, well, unconfirmed Googling shows, but by the way, I love that line, unconfirmed Googling. Says that it's dextrose monohydrate, which is going to be about 9% water, which will increase the molecular weight. And that's kind of interesting because the spread between the two answers is about 9%, so that seemed to work. Michelle Lynn was very happy that she was being vindicated here. She was like, yeah, that seems to be right. And then we got confirmation from Brian Hayes, who is a pharmacist in Maryland, who said, yeah, it is dextrose monohydrate, not dextrose. So D5W is kind of a misnomer. It really isn't dextrose water. It's dextrose monohydrate water. And that means that the explanation it is 252 is the right answer. But the important thing after that conversation is I collected all that data, I added a little bit of context, and I created a blog post, right? Because this is a great little bit of medical information, but it's going to disappear the next day and will be unfindable if you leave it on Twitter. But I collected everything, and I put it on a blog post. And now it's Googleable and it's searchable and anybody can come up with this answer. Here's the spread of the different people that participated. It was all over the country, all over at least North America. And the whole thing from the very first question to the end of the blog post took about 6 hours. And these type of things, they happen relatively frequently. They're absolutely wonderful and they really add to the character and warmth of medical information. However, this is not everybody's experience. A lot of this happens for myself because I have a very rich Twitter network, right? I have 5,000 followers and I follow about 1,400 people. And for people that don't have this type of personal learning network, Twitter is a very different experience, right? You come here and you look at it and there's all these great conversations going from people, you're going between people and you want to join. So you come in the end and it's easy to follow people and you can hear what other people are saying, but if they don't follow you, they can't hear things. It's like you're mute. And it actually can be really frustrating to be able to hear, but not be able to speak. And this made it very difficult for us to expand, to get other people using these tools, which we find so useful. How do we get other people to join? And so our idea was to create a beacon, an event that drew like-minded people together so that they could quickly find out who to follow, other people could follow them, and rapidly build up their personal learning network. And so we have a couple of these. These are the tentpole events. And I want to talk about both of them. We'll start with Neph Madness. So Neph Madness is based on March Madness, which is a yearly basketball tournament for college basketball in the United States. And the way people participate, there are 64 teams that are invited to the tournament. They're laid out in these brackets, these single elimination brackets. And that fans all across the country make their predictions before the first game of what the outcome of all 63 matches will be to determine the winner. And if you think about 2 to the 63rd power, it is nearly impossible to get them all right. I believe Warren Buffett put up $1 billion to anybody who could get all 63 matches right. He still has his $1 billion. So what we did is we took 64 nephrology concepts in 8 different regions. And so here's the cardiorenal region. We brought in experts in each one of these regions to help us figure out the 8 best concepts. Phyllis August is a woman who spent her entire life doing obstetric nephrology, the field that puts most nephrologists into a cold sweat. Getting a call from the obstetric ward just is terrifying. Alon Friedman from Indiana University helped us with the nutrition bracket. We got Conal O'Shea. He did a basic science bracket on genetics, which is great. Every year that we've done Neph Madness, we've had a basic science group. I can't make heads or tail of it. It's way too complex for me. I'm absolutely clinician. We had Samir Gupta, who's an expert in HIV-associated kidney disease, did our infectious disease bracket. Timmy Lee did our vascular surgery bracket, and Mitch Rosner did our onconephrology or nephrology and cancer bracket. And then we take over the American Journal of Kidney Diseases blog. They have a very serious blog where they cover all the different aspects of kidney disease that's covered in their journal. And then we Neph Madness! It's totally insane. I don't know, I still don't believe that they let us do this. It's really great. And then when you can drill down, and every one of the 64 concepts, we do pretty deep review we call them scouting reports. So as if this was actually a basketball team, and we'll review all the literature that supports that group. And we'll of course, we'll have links to the primary literature, so these are all, evidence-based. And these things still are around, and you can pull them up. And we actually have a product called Neph Madness Unplugged, where you can download all the text that we create. We create about 100 pages of text to support these 64 teams. And then after you've kind of reviewed it and you know all the teams, you go to the brackets and you fill out your brackets. You make your predictions of which ones are going to win. Now, and then again, it's kind of difficult. You can't remember what's sacubitril, so you can just mouse over it, and then we get a little pop-up that'll give you a paragraph description with a link to the full scouting report, and of course the hashtag, because we try to go all social media. And it would be great if we could really have tolvaptan play sacubitril in a basketball game. But unfortunately, we have to use a blue ribbon panel to determine the winners of each one of these rounds. And we got a great panel. We have 2 different journal editors. We have an instructor from Harvard. We have a chair of the American Society of Nephrology's training program directors. We have a professor of medicine from NYU. And we have the chief of Medscape Nephrology that all weigh in on which one of these teams should win, which was good because originally it was me and my co-creator that did this, and that caused a lot of controversy. People didn't like our opinions so much. So this works much better. And so this is how it went down. Here was our brackets with 64 teams. There's the round of 32, the Sweet 16, the Elite 8. The final 4 was sudden cardiac death and dialysis, SFLT1, which is both a biomarker for preeclampsia and probably the cause of preeclampsia, ApoL1, the most powerful genetic risk factor in African Americans for chronic kidney disease, and TKI toxicity this is in a chemotherapeutic agent in renal, has a very specific renal toxicity that's quite interesting. Our finals were ApoL1 versus SFLT1, and our champion was ApoL1. And we got 2 editorials by the twin Friedmans, Barry and David Friedman. Each wrote an editorial about this. And if you go to the original paper in Nature about ApoL1, David Friedman was the 2nd author, and Barry Friedman was the 6th author. And they wrote these. And actually, both these editorials were then published in AJKD, which was actually pretty cool, kind of reversing the normal publication chain. Among the players, we had hundreds of people enter this and try to do their best. This was the winning team, Manjula Tamura and Yiming Lit. And they filled out their brackets when they were in the VA nephrology clinic. They had some fellows and some medical students and some residents that were there. And over an afternoon, they kind of filled it all out. And they submitted theirs, and they won. The names are pretty familiar to nephrologists because Manjula Tamura is the author of what I think is the most important paper on dialysis among the elderly in nursing homes. And so it was neat to have somebody of some note end up winning. So that's Neph Madness. I want to talk a little bit about DREAM RCT. So nephrology has the unfortunate reputation of being really not very evidence-based. That of all the medical specialties, we have the least number of references to randomized controlled trials in our literature, which is really unfortunate. And so we want to be evidence-based medicine, but unfortunately, nephrology is really what we call eminence-based medicine, that the longest coat really determines what is right. And this has resulted in real patient harm. So just 3 examples. So aluminum-based binders were the way that we lowered phosphorus in dialysis patients in the early 90s until we realized that we were causing dementia and brittle bones. So it was really a horrible thing. Normalization of hemoglobin came out maybe 5 or 6 years ago. This was standard of care. Even our guidelines were saying, hey, raise that hemoglobin up using these drugs. Bring that hemoglobin to 13 or 14, and it'll be really good for the heart. And it kind of intuitively made sense that the anemia may be bad for these patients. And when we finally did the proper randomized controlled trials, we found that we were causing heart attacks and strokes and probably cancer. It was a real disaster. We don't do that anymore. And lastly, a combination of ACEs and ARBs. So proteinuria to the nephrologist is anathema. We hate it. And these combination of these two drugs really pushed down the proteinuria, so it made sense that we really should do this. Get rid of that protein in the urine, we probably will benefit the patient. Again, when we ultimately did the randomized controlled trials, instead of slowing the rate to dialysis, it actually accelerated it and caused a lot of hyperkalemia and hospitalization. So again, we don't do that anymore. 3 others, these were all about the dose of dialysis. There was a principle that if a little dialysis keeps you alive, a lot of dialysis will keep you alive longer. And again, it was accepted without proper randomized controlled trials. It became standard of care. And in every place that we did it, when we ultimately did the proper design, it didn't help at all. This didn't harm anybody, but it really caused a tremendous amount of inconvenience to both patients and physicians alike, and then for no gain whatsoever. And so what we decided what was needed is we needed more randomized controlled trials. And to try to encourage this, we created what we call a Shark Tank, but for science. And I'm not sure, Shark Tank's kind of an American phenomenon, so maybe you can think of it as Kickstarter meets NIH. And so we tried to crowdsource ideas for randomized controlled trials and then get the crowd to support which ones they thought were most important. So we picked out 16 people to come up with randomized controlled trials that were needed to be done. And so here's a typical one. This is the no-dot trial. And the no-dot trial looks at using diuretics at the beginning of dialysis. So when somebody's kidneys fail, they still make some urine, and some nephrologists like to load them up with high-dose Lasix or furosemide, keep that urine going, and it seems to be beneficial to patients. But lots of things that seem beneficial may or may not be beneficial, and this has never been studied. And so he wanted to do a randomized controlled trial, and he spends about 2/3 of this description just talking about why this trial needs to be done, and about the last third about how the trial would be done with outcomes and power analysis and all the kind of things you would see in the introduction of a trial with a bunch of references at the bottom. Everybody who reads these gets a chance to register. When you register, you're given $100,000 of virtual money to assign to the different trials. You could put $100,000 on one trial, you could put $10,000 on 10 trials, however you wanted to distribute it. And then we also got a group of distinguished scientists to also do that, and we set them aside so we could see how they compared to the crowd. And so here are our 16. Our winners is the Castaway Trial, which was a trial of different forms of dialysis and treatment in multiple myeloma-induced acute renal failure. MAGIC was a trial varying concentrations of potassium and magnesium in dialysate. But the ALK-PHOS is the one I want to talk about because I think this is a very interesting trial. Both of its banality and how it did with the researchers. So there are 2 types of kidney stones. 85% of kidney stones are calcium oxalate stones. And we treat those with a drug called Urocit-K, which is potassium citrate. And it works by 2 ways. One, citrate prevents kidney stones. So giving people more citrate lowers the need for lowers kidney stones. And the other thing it does is it increases the pH of the urine, which also makes calcium oxalate more dissolvable, less likely to precipitate into a stone. But 15% of kidney stones are calcium phosphate. Now, calcium phosphate would also benefit from the citrate in Urocit-K. But alkalinizing the urine actually promotes the creation of calcium phosphate stones. And so the typical question we have is, can we use Urocit-K, which has one ingredient that should be beneficial and one ingredient that should be harmful? Should we use those in calcium phosphate stones? And it has never been studied. And you get these people that are stone experts that look at the chemistry of urine all day long, and you get half of them saying one thing and half of them saying the other. And all it needs is a proper randomized controlled trial, but it's never been done. And I loved that when this became possible, the crowd said yes, finally, people were begging for this. Here's our virtual study section. It's a great group. Jay Coyner is an acute kidney injury specialist. John DeGurtis is the author of one of the most important trials in clinical nephrology on dialysis dose. Alan Nissenson is the medical director of DaVita. He is responsible for the dialysis of 60,000 people a week. Manjula Tamura won Neph Madness. We brought her back for DREAM RCT. Uptal Patel runs clinical trials at Duke, and Jonathan Hibble-Farb is the president of a small organization called the American Society of Nephrology. When he said yes, I fainted. And so their answers ended up looking very different. You can see all of our top choices fell dramatically among the experts. And the ones that ended up winning were trials that, I'm not saying they're unimportant, but it was a very different collection of trials. And I think this might explain some of clinicians' frustration with the medical literature. They're just not answering the questions that we need to treat patients. The last thing I want to talk about is the journal club that we do. What we found is that we would bring a lot of people in for these tentpole events, and they had a great time during Neph Madness or during Dream RCT, and then afterwards they didn't know what to do because we brought them in for a very specific thing, and they kind of drifted away. We needed a constant drumbeat to bring them in, to train them on how to use social media. And so we think the answer is Twitter journal clubs. These were invented by Fee Douglas and Natalie Sylvie. They created TwitJC, which was a general journal club for Twitter, and they got covered in Nature. And so you know what happens as soon as they're covered in Nature. Immediately everybody else wants to do the same thing. So there are 6 other ones, and we are another one right here. And so the way it works, my partner is Swapnil Hiremath. We brought in 3 Europeans because we do a European chat. We brought in another couple people later on, Edgar Lerma and Graham Abra, and then we've fortified us with Matt Sparks, Suzanne Norby from Mayo, and Hector Madariaga from Maryland. We start out with a blog post describing the article that we're going to cover. This is kind of typically what it looks like. And this is the Achilles heel of a journal club is you come to the discussion, you haven't read the article. And this is how we inoculate people there. It gives you a 5-minute summary of the article. It's about twice as long as the abstract. It includes the key figures from the story. After that, every Monday, the chat's on Tuesday and Wednesday. Every Monday, we send out a newsletter describing what we're going to be talking about. And then we have the chat. And the chat happens on Twitter, and I think Twitter is an excellent medium for going through a journal club. It's the right duration. People can get their points across well enough. It gives great ability to do two-way conversations, and people talk back and forth. Some people bring in images and articles and links to other articles. It ends up being a great way of doing this. And then we do this twice a week, once for an hour-long chat for North America at 9 p.m., and then another one the following day at 8 p.m. at Greenwich Mean Time for Africa and Europe. And they're about equal in size. And then after we're all done, we take a summary of what we did, and it actually gets posted to PubMed. And this is a new initiative on PubMed, and they want to bring in post-publication peer review. And that they feel that these journal clubs are a great way of doing this. So this has been a real interesting format for us to add this and kind of become a permanent part of the medical record. And we've done close to 50 of these now. On average, we get about 500 tweets for each journal club. We get about 50 people participating in each one between the two chats. And so this is our schema for bringing people in and making social media a little bit more nutritious. We call it digital mentorship. And if you want to learn more about it, you can go to our website, nefjc.com, and explore all about it. Specifically, nefjc.com/digital mentorship. That's going to have links to some of our poster presentations that we've done and allow you to download the Neph Madness Unplugged and Dream RCT Unplugged.